In this video tutorial, I'll be going over 4 problems from section 4.3 and 4.5. So the first problem wants us to find the local extrema of f of x. And it gives us f of x is equal to 2x to the third minus 36x squared plus 120x plus 6. And local extrema are just the local max or local min. So the first thing we should do is to find the critical points. So the critical points can be found where the derivative is equal to 0 or the derivative does not exist. So I found the derivative to be 6x squared minus 72x plus 120, and I set that equal to 0. And after factoring, I found that x equals 10 and x equals 2, so those are my critical points. And since the derivative always exists, for D and E you can just put none. So is 2, 118 a local max or a local min? Well, if you find the second derivative and plug in x equals 2, then you would get a negative number, so that means it's concave down. And if it's concave down, that means it must be a local maximum. And for the other point, is 10, negative 394 a local max or min? Well, you can do the same test. So if you find the second derivative and plug in x equals 10, you'll get a positive number, and that means it's concave up, which means it's a local minimum. So those are our 2 answers for problem 1. Problem 2. The first thing this question wants us to do is to find the inflection points. Then it wants us to find the intervals where f of x is concave up and concave down. So the function we're given is x to the fourth minus 6x to the third. So to find the inflection points, we find the first derivative, which is 4x to the third minus 18x squared, and then we find the second derivative, which I found to be 12x squared minus 32x. And to find the inflection points, you just set that equal to 0 and solve for x. So I found that x is equal to 0 and x is equal to 3. So the next thing you want to do is make a number line. Making a number line will help you find the intervals of concavity. So on my number line, I put x equals 0 and x equals 3, and then I tested some values around 0 and 3. So I used -1, +1, and +5. And what I found was that the first interval was positive, the second interval was negative, and the last interval was positive. So that means that the first interval was concave up, the second interval was concave down, and the last interval was concave up again. So from our number line, we can conclude that the function is concave up from -infinity to 0 and from 3 to +infinity. It's concave down from 0 to 3. So that's the final answer for problem 2. For problem 3, it gives us the function f of x is equal to x times the square root of x squared plus 36 on the interval -4 to 7. The question asks us to find 5 things: concave down, concave up, the inflection points, and the local min and max. So the first step that we should do is find the first derivative. So to do this, I use the product rule, which is f prime g plus f g prime, and I found f prime g and f and g prime, and I plugged in each component into the formula. So I got that my derivative is equal to 1 times the square root of x squared plus 36 plus x times x over the square root of x squared plus 36. So step 2 is to find the critical points. And the critical points are when the first derivative is equal to 0 or it doesn't exist. So, looking at the numerator, we can find when the first derivative is equal to 0. And I found that there's no real solutions. So I did 2x squared plus 36 equals 0, solved for x, and I got x equals the square root of a negative number, which is imaginary. So there's no real solutions there. And then when I looked at the denominator, which is the square root of x squared plus 36, I found that x always exists from -4 to 7 on that interval, so there's no DNE there. So the conclusion is that there are no critical points. The next step is to find the second derivative. So we already know that the first derivative is 2x squared plus 36 over the square root of x squared plus 36 after simplifying it with arithmetic. So to find the derivative of the first derivative, we can use the quotient rule, which is low d high minus high d low over low squared. So I found what low, d high, and d low are, and then I plugged them in. And then I did some more arithmetic to simplify. And then the final form that I found for the second derivative was 2x cubed plus 108x over x squared plus 36 to the 3/2 power. So that's the second derivative, simplified. Now the next step is to actually find the inflection points, which is when the second derivative is either equal to 0 or it does not exist. So if we look at the numerator, we can see that x equals 0. And why is that? Well, we can use the zero product property to find the x values individually. So the first factor was 2x, so I set that equal to 0, and I found that x equals 0. And for the next factor, I got x squared equals -54, and when you take the square root of both sides, you get x equals square root of a negative number, which is, again, imaginary. We should also remember to check the denominator to make sure that there's no x values that don't exist on the interval -4 to 7. So we can already tell, just by looking at this expression, that whatever number you plug in there is always going to bring a positive result. So I can confidently say that x always exists in this interval. So the only real inflection point that I found was x equals 0. So next thing we should do is test the intervals for concavity. So I drew another number line with the endpoints, -4 and 7, and also the inflection point that I found, which was x equals 0. And then I plugged in some x values, like -1 and 1, into the second derivative to test for concavity in those intervals. So for the first interval, I found that it has a negative concavity, and the second interval was positive. So we can fill in the answers here. So far we have that it's concave down from -4 to 0, and concave up from 0 to 7. The inflection point we found was x equals 0 or 0, 0. Now we just need to find the local minimum and the local maximum. So about that, we should remember that since there were no critical points, we know that the local min or max must be at the endpoints. So I tested the endpoints, and I got f of -4 equals -28.84, and f of 7 equals 64.54. So at x equals -4, we have a local minimum, and the y value is -28.84. And then at x equals 7, we have a local maximum, because the y value is a positive number, 64.54. And if we want to write them as points, we can just write -4, -28.84, and 7, 64.54. So now we have all our answers to the question. Problem 4. The function f of x is equal to negative 2x cubed plus 30x squared minus 144x plus 7 has one local minimum and one local maximum. This function has a local minimum at x equals blank with value blank, and a local maximum at x equals blank with value blank. So this question wants us to find the local min and max and also find both the x and y values of each. So the first thing we should do is find the critical points. So I found the first derivative, which was negative 6x squared plus 60x minus 144, and I factored it. And the x values I found were x equals 6 and x equals 4. So those are our critical points. We also know that x will always exist, so we don't have to check for DNE. Then we should make a number line to help visualize what we found. So we found that x equals 4 and x equals 6. So I tested some values on the first derivative on the 3 intervals. So the first interval was negative, which means it's decreasing. The second interval was positive, increasing, and the last interval was decreasing because it was negative. So a change from decreasing to increasing means that there's going to be a local minimum there. And a change from increasing to decreasing means that there's a local maximum. So we can conclude that we have a local min at x equals 4 and a local max at x equals 6. And if we want to find the y values to write it as a point, we can just plug it in to the function, and I got negative 217 for x equals 4 and negative 209 for x equals 6. So our final answer is that we have a local min at 4, negative 217 and a local max at 6, negative 209. Thanks for watching!